Okay, so I wanted to provide you with a little bit of homework help on some problems in Lesson 6.6. So I've selected a few problems. So here's numbers 28 and 29. Taking these given decimal equivalents, log base 5 of 3, log base 5 of 4, let's see if we can come up with a product or a quotient. We're going to try to use our properties to rewrite this and utilize the properties to incorporate these decimals that we're given and try to come up with our answer. So this one's takes a little bit of creativity because the way to come up with 40 would be 4 times 10, 8 times 5. Well, I can, even though I'm not given log base 5 of 5, that's something that's easy to evaluate. Obviously, log base 5 of 5 is 1. So if I could take log base 5 of 5 times something, obviously 5 times 8 would give me 40. But the question becomes, how do I come up with 8 with what I'm given? And if you think about it, you can use a fraction exponent for 4. If you raise 4 to the 3/2 power, that's the same thing as the square root of 4 to the third. And the square root of 4 is 2, 2 to the third is 8. So that's another way of representing 8 using a rational exponent. Okay, so we've set it up so that now we're going to use the product property, and we're also going to utilize the power property as well. So using the product property, we would have log base 5 of 5 plus, remember, for the number of terms that we have multiplied, we'll have that many logs separated by addition. So we're going to have log base 5 of 4 to the 3/2 power. Log base 5 of 5, we've already said, is 1 plus, and let's use the power property to treat this exponent 3/2 as a factor. So just bring it down and write this as 3/2 log base 5, 4. And now we can go to what we have been given, 1 plus, let's go to our calculator, and we're just going to take this decimal 0.8614 and multiply it by 3/2. So times 3 divided by 2, and then we'll be ready to add these together. So 0.8614 times 3 divided by 2 is 1.2921. And now we just add 1 to that, and we'll have our final answer of 2.2921. Okay, so there's your answer for number 28. Here's number 29. So now we got to find another way of coming up with 30 using either a product or a quotient. I know that 5 times 6 is 30. So once again, log base 5 of 5 times 6, but unfortunately I'm not given 6. So I can take advantage of the fact that I am given log base 5 of 4, and sort of like what we did in this problem, if I raise 4 to the 1/2 power, I get 2. Okay, so 4 to the 1/2. And then I've got this log base 5 of 3, so I can utilize that. So this is like 5 times 2, 4 to the 1/2 times 3. And this is another way of writing log base 5 of 30. 5 times 2 times 3 is 30. So now let's use our product property again. Log base 5 of 5 plus log base 5 of 4. Should be 5 here. 4 to the 1/2 plus log base 5 of 3. Of course, log base 5 of 5 is 1. This is log base 5 of 2. Well, to use the power property, let's write it as 1/2 log base 5 of 4. And I'll just bring this other one down as well. So we're given log base 5 of 4 is 0.8614, so all we have to do is divide that by 2 or multiply by half. And that's 0.4037, 4307. And then we're given log base 5 of 3, 0.6826. And now we just have to add these together. And that gives us our final answer of 2.1133. It's the answer for number 29. All right, then we get to some log equations, and we're still utilizing the properties. On the left side of the equation, you notice we have two different logs. So it's always true for these equations, these log equations, that multiple logs, in this case 2, need to be combined into one. All right, and when two logs of the same base are being subtracted, we can write this as a single log of that base using division. So this left side of the equation using the quotient property will look like this: 100 divided by y plus 5, and that's going to equal log base 7 of 10. Now, we mentioned in class today, I introduced you, your book actually doesn't do this for another couple of lessons, but I think we might as well go ahead and introduce it today. We have another handy property. It's called the log property of equality. And it says if you have logs, one log on either side of the equation, as long as it has the same base, then basically you can basically let the logs cancel each other out. And we're going to solve this equation: 100 over y plus 5 equals 10. All right, I'm going to multiply by y plus 5 on both sides. 100 equals 10y plus 50. And then I'm going to subtract 50 and divide by 10. And I get y is equal to 5, but it's always a good idea to double check it and make sure. And so if I let y be 5, I get, this would be log base 7 100 minus log base 7 10, 5 of size 10. And does that equal log base 7 10? So according to the quotient property, these two logs being subtracted could be written as a division problem, which would be log base 7 of 100 divided by 10, which is 10. So this actually does check out. And so my answer for number 39 is going to be y equals 5. Here's another one. Again, using the quotient property and the power property. So it's always going to be true that you cannot combine two different logs unless you clear out this space. In this case, I've got to move this 3. So you can never combine logarithms if there's a factor in front of the log. So my first move will be to use the power property and turn this into this. The 3 can just be moved and it becomes an exponent for x. Okay, now I'm going to use the quotient property, which says that these two logs of the same base that are being subtracted can be put together as a single log using that base and division. All right, and once again, I'm going to apply the log property of equality. And since I've got single logs on either side of the equation, these logs will just cancel each other. And 6n over x cubed equals x. And I'm supposed to solve for n, so I'm going to multiply by x cubed on both sides. And I'm going to divide by 6 on both sides. And that is my answer solved for n, so you could check this out. If you replace n with x to the 4th over 6. Let me just do a little check right here. So log base a of 6 times x to the 4th over 6 minus 3 log base a of x. Does that equal log base a of x? Okay, so when I do multiply these together, I'm just going to get log base a of x to the 4th. And this becomes log base a of x to the 3rd. All right, using the power property. And I want to know, does that equal log base a of x? Well, using the quotient property, this would be log base a of x to the 4th divided by x to the 3rd, which would become log base a of x to the 1st. So that is my answer for n, x to the 4th divided by 6. All right, here's another one. I'm going to do, before I can put these together, these factors like 2 and 6 need to be moved. They need to become exponents. So log base b of 16 squared plus log base b of n to the 6th equals log base b of x minus 2. Multiple logs need to be joined together, and since these are being added, I can use the product property. Log base b of, let's just go ahead and do 16 squared. And that's 256 n to the 6th equals log base b x minus 2. And once again, at this point, you can employ the log property of equality. So 256 n to the 6th equals x minus 2. And we're supposed to be solving for n in this case. And so let's divide by 256. So to solve for n, I need to raise both sides of this equation to the 1/6 power. And you can actually just leave your answer in this form. N is going to be, this is actually your answer, x minus 2 over 256, all raised to the 1/6 power. Or you could think of it as the 6th root of that fraction. If you wrote it like this, that would be okay. All right, so that's 43. That is your answer. And let's try this one. This is number 46. So once again, multiple logs need to be joined together. And I've actually got the base erased on this one, so let me put it back in. So that should be log base 2. You can't use these properties unless the bases are the same in your log expressions. So the quotient property says these two logs that are being subtracted can be put together as a single log using division. And if you're dividing, you should put parentheses around the fraction part of this log expression. Okay, well, this one's a little different because previously we had, you could do this one of two ways, but I want you to really drill the properties. That's why I'm doing it this particular way. I could have added log on both sides, but actually that wouldn't help a whole lot since I have this constant 1 on the right side. So this is probably the best way to go about it, to use the quotient property. And now we can't apply that log property of equality because we don't have logs on either side, single logs on either side of the equation. So what I'm going to do here is what we've learned in the past. How do I turn log equation form into exponential equation form? So remember, I take the base of the log, and that's going to become the base for some exponent. Remember that the short definition we gave to logarithms is that they are exponents. So if you're looking at a log equation, just read it like this. The log is 1, or you could just as easily say the exponent is 1. So 2 is going to be raised to the first power, and then I'm just going to let that equal everything else. Okay, and we're solving for b, of course, so I'm going to multiply by this denominator on both sides of the equation. So we're going to be distributing 2. And when I multiply by the denominator, it turns my equation into this. So I basically cleared out the denominator. If you want to see a step, I cleared out the denominator by multiplying by this on both sides. So we distributed 2, those would cancel, and now it looks like we're going to have a quadratic equation, and I'm going to make this equal to 0. I prefer my quadratic equations having a positive quadratic term, because if it will factor, that's the way they factor, with this positive term here in front of b squared. So I'm just going to set this equal to 0 going this way. 2b squared plus 15b minus 17. Okay, so I added 2b squared, I subtracted 2, and now we want to see if maybe factoring is possible, and you could test, see if the box method could be used. So the first and last terms multiplied together would be negative 34b squared. And so I'm looking for factors of negative 34b squared that would add up to 15b. And they do exist, 17b and negative 2b. So I can use the box method. Let's just go ahead and do that real fast. 2b squared, negative 17. My terms are going to go here. Doesn't really matter which order. And so going across the top, the GCF would be b. This GCF would be negative 1. So b minus 1 is 1. All right, and then going vertically, this would be 2b, and this would be 17. 2b plus 17. So just a quick check, 2b squared plus 17b minus 2b. All right, so we have our solutions of b is equal to 1 and b is equal to negative 17 halves, or negative 8.5. So let's take a look. We want to make sure that these actually work. Keep in mind that you cannot evaluate the log of anything negative. Okay, you also can't evaluate log 0. There is no way to raise a number to a power and get 0. Well, if we let b be 1, that's what's going to happen. 15 times 1 is 15, minus 15 is 0. If it makes either of these, doesn't have to make both, but if it causes log of a negative or log of 0 in either one, then we can't use it as a solution. So I'm crossing out b is equal to 1. It's not possible. And then we can test negative 17 over 2. Well, if you test that one, it's going to create a problem also. It's going to create a negative. So you can kind of see that right here. This is the opposite of b squared. It's not negative b being squared. It's the opposite of b squared. Well, the opposite of, if you did negative 17 halves and squared it, that would be positive, but now this is going to turn it to negative. And when you add these together, you're going to have a negative result. So I got a log of 0, which is not allowed, and we also got log of a negative number, which is not allowed. So in this case, we ended up with 2 possible solutions, but we can't use either one of them. So therefore, the answer for number 46 is going to be no solution. Okay, hopefully that made sense, but you should always do at least a mental check of your answers to make sure that it doesn't violate log of 0 or log of a negative number. All right, I think this is my last one, so let's put these logs together. Remember, logs, multiple log expressions need to be condensed or combined into single log form. So I'm just going to take them a pair at a time. I'm going to use the quotient property for this first two pairs. So that would be log base 7 of 64 divided by 8/3. All right, and we'll just take it one step at a time. And dividing by 8/3 is the same thing as multiplying by 3/8. So 64 times 3/8. I can do a little cross canceling here and I get 24. So log base 7, 24 plus log base 7, 2. Get this out of the way. Equals log base 7, 4p. Now I can use the product property. These two logs that are being added can be joined together as a single log using multiplication. So that's log base 7, 48. So I got log base 7, 48 on the left side, and I just brought down the log base 7, 4p on the right. Well, now we can once again utilize that log property of equality. So basically, single log on either side of the equation, they're the same base. So I can mark these out and makes it become pretty simple. I'm going to solve for p, and looks like p is going to be 12. And you just want to double check again and make sure that that doesn't violate. I would basically just go ahead and make this become log base 7, 48 and see if you can use your properties on the left side and come up with log base 7, 48 just to give yourself some assurance. But at the very least, make sure that this number does not create log of a negative or log of 0. Generally, if it doesn't do those two things, you're in good shape, but that's not 100% of the time. So I think it's always a good idea to do at least a mental math check, or if you really want to be safe, just go ahead. If you've got time on the test, just go ahead and check it out and make sure it works. But that does work. I can tell you that in this case. And that's it. So that should help you out with the lesson 6.6 homework. And if you have any questions, let me know.